Hello and welcome to this video where we're going to carry on preparing for A-level chemistry by looking at the charges on ions. To do this you're going to need to understand how to read atomic symbols and also how to draw electron configuration diagrams from our previous lesson. Let's begin. So this content relates directly back to your GCSEs where you would have looked at electron configurations and how electrons are arranged in energy shells. You would have looked at ions and hopefully remember that ions are atoms with a charge, either positive or negative, and also how to work out the magnitude of those charges. We're going to do a quick refresher on this to prepare you for your A-level studies. We should remember from GCSE that on the periodic table there is a divide, quite an important divide. It runs approximately like this. Now, why is this divide so important? Well, because it determines which type of atoms we're looking at. On this side of the divide, we've got metals, whereas on this side of the divide, the remaining elements are classed as non-metals. Now, metals all form positive ions by losing electrons, whereas non-metals all form negative ions by gaining electrons. Remember, when you form an ion, it's only the number of electrons that changes. All the other subatomic particles are present in the same quantities as the neutral atom. It's only ever the number of electrons that changes. Let's have a look at how we can work out the charge on ions of different elements. We'll start by having a look at magnesium. Now we should hopefully be able to remember, or find out from our periodic tables, that magnesium has an atomic number of 12. Now remember, because it's a neutral atom at the first instance, because it has 12 protons, it will also have 12 electrons, which are arranged like so in its energy levels, yet again filling the shell singly until they're at least half full. So you can see that magnesium here has 2 valence electrons, and because it's a metal, it's going to lose those electrons, so it's got an empty valence shell when it forms an ion. So we can redraw that on this next set here. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons there in those 2 shells. The valence shell is now empty. We're going to put square brackets around it and a 2 plus charge there because it's a metal. It's lost 2 electrons and so it became positively charged. And because it's lost 2 electrons, that charge is equal to 2 plus. So all elements in group 2 will form a 2 plus charge, and all elements in group 1 form a 1 plus charge, etc., etc. What about charges on non-metals? Let's have a look at those next. So here we have fluorine. Fluorine is a non-metal, and yet again we should hopefully remember, or be able to find out, that it has an atomic number of 9. So that means it's got 9 protons in its nucleus, and a neutral atom of fluorine therefore has 9 electrons. Now because fluorine is a non-metal, it wants to gain electrons when it forms ions, which means that it's going to form a negative ion. So as a non-metal, what it's going to do is it's going to gain as many electrons as it needs to fill that outer shell. So I'm going to represent the electron it gains here on this second representation with that red dot. So fluorine now has 1 more electron than it has protons. And this means that the fluorine is going to form a 1 minus ion, which we can denote simply with a minus charge there. So all elements in group 7, the halides, are going to form 1 minus ions. All elements in group 6 will form 2 minus ions, so on and so forth. Remember, metals form positive ions, they lose electrons. Non-metals form negative ions, they gain electrons. Okay, so that's been a bit of a crash course refresher on ions, drawing the electron configuration of ions and working out their charges. As you get more comfortable with it, you will remember the charges that different atoms form based on their group number, but it really does take that practice. It's worth looking ahead now to how you can use ions to try and work out chemical formulae, as well as looking at writing ionic equations, which I know a lot of students find quite challenging from their GCSE studies. Watch out for the video on that coming up soon. Hope this has been helpful. Don't forget to like and subscribe. I've been Mr. Harding. Thank you very much.